Okay, today we're going to look at the properties of quadrilaterals, and we're going to use those properties to solve for an unknown. Um, the first thing about quadrilaterals is that they've got four sides. It really helps if you understand this flow chart that you see here um, on the screen. We're going to look at a different flow chart right here. And a quadrilateral's got four sides. And anything with four straight sides is a four-sided polygon, is a quadrilateral. If the sides are parallel, then it's called a parallelogram. And then you have all these different things here, different parallelograms with different names. But the way that the flow chart's really important, it tells you the ones that are below are all part of the quadrilaterals that are above it. So it turns out that a square is actually a special type of rectangle. It has all the properties of a rectangle when we look at them. And a rhombus is actually a square is a special type of rhombus. And all of these three are special types of parallelograms. So a trapezium has one pair of parallel sides. So if you understand this flow chart and you can read it, it can solve all sorts of problems when you have to classify a quadrilateral. But what you really have to know is the properties. A parallelogram's got two pairs of parallel sides that are equal to each other, and the opposite angles are equal to each other, and the diagonals cut each other into two equal pieces. The diagonals bisect. A rectangle's got all of those properties except there's 90 degrees in the corner. And a square has got all those properties, but the square has all the sides that are the same length, and all the angles being 90 degrees. A rhombus has all the properties of a parallelogram, but what's kind of special about it is the diagonals come together at 90 degrees, and all the sides are the same. Okay, and you're going to have these notes. You need to look at the properties of a kite and the adjacent sides that are equal. And one of the sides that cuts across, the shorter side here, it gets bisected by the other diagonal. Okay, and there's 1, 2, 3, 4, 5, 6, 7, 8 geometry reasons from grades 7 and 8 and 9 that you just need to use all the time, all the way to grade 12, as long as you do and stay in geometry. The first one is the angles in a triangle add to 180 degrees. That if you've got two sides that are equal, the two angles are equal. That if you cross two lines, the angles opposite are equal. That the angles in a line add up to 180 degrees. That if you extend an angle in a triangle, it's called an exterior angle, and it equals the sum of the opposite interior angles. This little shorthand you see is all you have to write down for the reason, exterior angle of a triangle. There's three parallel reasons. Alternate angles are equal. Corresponding angles are equal, and co-interior angles, the angles inside two parallel lines, they sum to 180, just like the angles in a line and the angles in a triangle. Now we're going to look at the kind of questions we have to do. At first, it seems really kind of difficult, but it's not so difficult, really, if you use your properties and you think about things logical. There's usually more than one way to do it, but you've got to use your geometry reasons to logically find the missing parts. Okay, and when you find X, it's the very last step. So all you're given here, like read this really carefully. We want to find this little X up here that's actually angled TQR. You're given that PQRS is a parallelogram. So all the sides are parallel, and the opposite sides are equal to each other. And you're given that PT equals RT, and it equals RQ. So that's what you're given. Well, you have to start off, you're trying to get at X, but you're given this angle here. We're going to try and figure out what this angle by S is. So this is the first thing you notice is that PS equals PQ. because the opposite sides of a parallelogram are equal. So that's your first step. And now you know that PS must equal to PT because it's given that PT is equal to QR. That's actually got a name. It's called a transitive property. We could do that. But the next thing, now that you know that those two sides are equal, that PS is equal to PT, now you can get at this angle here. There are two things. That angle where S is and the angle PTS, they've got to be exactly the same angle because the sides are the same. And all three of these angles have to add up to 180 degrees. Well, that's why S has to be 70 degrees. And the reason is the angles in a triangle have to add up to 180. So what you do is you go 180, you take away the 40, you're left with 140, and then you divide it by 2. So both of those angles, PTS and S, must be 70. But we get S is 70 from two reasons. Equal angles opposite equal sides, and angles sum in a triangle. Well, now you've got two parallel sides, and angle S and angle R are co-interior angles. So if S is 70, R has got to be 110 because co-interior angles sum to 180, and PS is parallel to QR. That's why you're allowed to do that. Now we've got R is 110 degrees. Well, now you're just about finished because you know you've got two sides here that are equal. That makes these two angles equal. Well, that one's X, so this one over here has to be X. Well, we know that's 110, so we go 180 minus 110 and we get 70. And they both have to be the same, so we divide 70 by 2. We get X is equal to 35 degrees. But the reason we know it's 35 degrees is because opposite angles are equal opposite equal sides, and the angles in the triangle have to sum, and we know that's 110. So you subtract it from 180, cut it in half, and you get your final answer. So you're going to get all these notes, and you can look it over carefully and play the video again if you have to, because, well, I guess it is sort of challenging. We're going to try a couple of questions, and that's what the questions are going to look like. The first one is exactly like I've just changed the angle, so just go through the steps and do the best you can. So we'll see this now. I've got to take this off now. I'm going to take it up, and now I'm going to stop recording in just a second.